All right, so this video talks about when you're writing the equation of a line and you want it to be parallel or perpendicular to another line that they give you, okay? And just to be sure, whenever we do these equations, I'm going to make sure it's in slope-intercept form, my final answer, okay? So slope-intercept form, which of course is y equals mx plus b. And just in case we need it, point slope form is y minus y1 equals mx minus x1. All right, and if you need an explanation of what those are and where they come from, check out some of my other videos, but because I've already explained it and I want to get to these. So numbers 59 through 69 here. So it's either parallel or perpendicular, only one of each. Let's do number 61, for example. Okay, so it says parallel to the line 2x minus y equals negative 2 containing the point 0, 0. So first of all, remember what the most important thing is I need for a linear equation is the slope. Okay, so notice how in this equation I am given the equation 2x minus y equals negative 2. So they don't tell me what the slope is. They give me the equation it's parallel to. But also notice in number 61, it's not in slope-intercept form or point-slope form. It's in a third kind of form called standard form. Okay, so standard form is another form of the equation, okay, which again kind of roughly is ax plus by equals c. All right, so x and y are the common x and y. A, b are just the coefficients in front, and c is a constant, just a number. But notice how in standard form, the variables are on the same side. So that's usually the big clue for students. When I see the variables on the same side, it's standard form, whereas slope-intercept form and point-slope form are on different sides of the equation. Okay, so if I take a look at 2x minus y equals negative 2, that's in standard form, which tells me nothing about the slope. So that means I need to rearrange it to either look like point-slope form, or I need to rearrange it to be in slope-intercept form. Most students are comfortable with slope-intercept form, so I'm going to rewrite this equation in slope-intercept form. So 2x minus y equals negative 2. And to do that, I just need to get y by itself. That's it. So I'm going to subtract 2x over here. And I can't combine negative 2 and negative 2x, so I'm just going to write them right next to each other, like this. And I can't leave my equation with a negative y, so I'm going to multiply them all by negative 1 or divide by negative 1 by everything here. So it's going to give me the equation y equals negative 2 divided by negative 1 is positive 2. And again, negative 2 divided by negative 1 is positive 2. So I just rewrote the equation from standard form to slope-intercept form, okay, which now tells me the slope, which is 2. And if it's parallel, that means it's the same exact slope. So the slope of my new equation, m is going to equal 2. And again, it says contains the point 0, 0. So 0, 0. So now this equation is just like all the ones we did previous. So I have a slope and I have a point. Oh, I can use point-slope form. How about that? So I'll do y minus 0 equals 2, x minus 0. Which, think about it for a second. Do I really need the zeros? I don't. So I can get rid of that 0. I can get rid of that 0. Hey, look at that. I already have my answer. Y equals 2x. All right? So that's what you do when it's parallel. All right? Now let's do it where it is perpendicular. So parallel, you got to have the same slope, especially if it is in slope-intercept form. In standard form. Change it to slope-intercept form so that you know what the slope is that you need. Okay? So like for example, let's do number 65. Okay, so it went away, but I'll bring it back, I promise. Watch this. It's fancy. All right, so number 65. Perpendicular to the line, y equals negative 1/2, x plus 4, containing the point 1 comma negative 2. All right, so perpendicular is, so where parallel is the same, perpendicular, you use the opposite reciprocal. Okay, so opposite reciprocal. All right, so if the slope of the other line was y equals 2x plus 2, okay, the slope being 2, the opposite reciprocal would be if it's positive, it becomes negative, and if it's negative, it becomes positive. So it becomes negative 2, and then you have to take the reciprocal, meaning you flip it over, which is going to be negative 1/2. So the opposite reciprocal of 2 is negative 1/2. Okay, so that's an example of opposite reciprocal. So taking a look at number 65, it says perpendicular to the line y equals 1/2 x plus 4. Notice how it's already in slope-intercept form. Perfect. We know what the slope is. So if the slope normally is 1/2, the opposite reciprocal would be negative 2 over 1, or we can just write negative 2. Okay, so the slope is negative 2 of my new line, and it contains the point 1, negative 2. Okay, so 1, negative 2. Now again, we're just right back to, we can just do the point slope form and get the equation in slope-intercept form again. So we're going to do y minus negative 2. Notice the double negative, super important. And we already know negative 2, x minus 1. Double negative becomes positive, distribute the negative 2. So y plus 2 equals negative 2x plus 2. Subtract 2 from both sides, and we get y equals negative 2x, and the 2 minus 2 cancel each other out. So there we go. There's my answer. All right, so opposite reciprocal for perpendicular. It's the same exact slope for parallel, and we'll talk about those special cases in another video.